So friends, I'm going to show you something right here. You see this thing is showing 3.58 amps, which is, you can see this pump says 4.4, so it's this pump running is what it's showing. And it may not be completely closed up, but you can see it shows 3.85, so about almost 4 amps. And I'm going to show you that the heat light is on. This is a Balboa system, so it is showing that it is heating. So why is it not drawing amperage? So let's go investigate. It's a very simple reason. All right, so I want you to see that it has voltage between the black and the red. First, we're going to check across the black and the red wire incoming. And you can see that we have 205 volts right there. Now we're going to check across the heater. So when you check edge to edge on the heater, or electrode to electrode, see I'm just touching each one, you see it shows 0. But if I check from either one of them to ground, it shows half voltage. So now let's look. This is, I'm going to keep it here. I'm going to go to the top relay right here. That relay, you can see, shows 204, 205. You go to where it jumps down to the bottom relay, the tandem, right here, shows 204, 205. To the output of the bottom relay, shows 204, 205. To here, it shows 9 volts. 1 volt, you see it's jumping around 0. So on the back of the board where this bottom tandem relay, the second relay, you see there's 2 relays stacked up, I'm going to have a cold solder joint on that relay. So in a moment I'm going to power down and pull the board out and I will fix that relay right there. So what I want you to look at is on the relay you see there's a tab there and a tab there. So each one of these things has 2 tabs on it, and what we're doing is jumping from tab to tab. Alright, so we lit this thing a little bit and zoomed in so you could see. So when I'm saying tandem relay, you see there's 2 relays here. So you've got the top relay and a bottom relay, and then there's a third relay over here. That relay powers the left-hand side. Let me zoom out just a little bit now that I've shown you that. So this relay powers the left-hand side. It powers this electrode. So when you power up, that relay closes, puts power here. That's why you always measure half voltage, 115 or so, from there to ground, or from here to ground when the system is not telling it to heat. And then on this side, there's always voltage here. So this is the red leg, this is the black leg. There's always voltage here on the first tab, and then you see there's a jumper from relay to relay, and what that does is solidifies the connection on the board between the 2 relays. So basically this is beefing up that connection. That's from the factory, and you can see this thing's damaged a little bit. I'm going to replace this little jumper too. It's gotten hot, you see that? Then, and I think that's because of the cold solder joint. So that's incoming voltage, that's outgoing with the relay closed, in, out. So when you check from here to here, you should have 240 volts. So let's see. I'm gonna move this right here where you can see it with the heater light on. And in this case, I showed you that the heater light is in fact on. So I'm gonna check between here, and this is a typical VS system. So any VS is going to show, and you see that it's showing 205 right there. So it is heating. It's telling it to heat. The voltage is just not getting down to the board. So there's a tab down here as well, and you can see that it shows 0. But if we go from this tab to here, you see it shows the voltage. So it is open on that bottom relay, the bottom relay on the right. There's a cold solder joint on it, that relay right there on the back of that board. I will open it up and show you. Stay tuned. All right, so I've got it undone. I'm gonna pull it out and show you. I haven't even looked at the back of it yet, but ta-da! You see that cold solder joint right there? So that is on the back of the board on that bottom relay, just like I said it would be. Now there's several different ways that we can solve this. I'm going to clean this up, see how bad it is, and I will show you how to fix it. But I'm going to show you again on the front of this. Now that we've got it out, it's a little easier to see. You got 3 relays related to the heater. This one is tied to this. So it's basically the red leg into this. So if you look, that's the red leg right there. You see it's red right there. Then it goes to this cluster and it goes to there, and then it jumps over. And then that's the turn on part of it. So that's this relay. So the red leg goes to here. So when you power up, if everything's good, this relay automatically closes and puts 110 on the heater all the time. Then if everything is good, high limits and everything, this one closes. And then this one is the one that closes and tells it to heat or not to heat. And you can see that there's a jumper, and that jumper's gotten really hot. And I think the reason it's gotten really hot is because of this cold solder joint. Now we have some lucky things here. One of them is we have a tab here that we can attach to, and you also have a tab here that you can attach to. So I could have simply, to solve this, I could have actually made a jumper and just jumped from here to there, and it would have made this thing heat. But I wanted you to be able to see on the back of the board, and all the boards don't have that extra tab right there. But that may be how I choose to fix this, just simply making a jumper from there to here, and then a new jumper from here to here. But that is why she's not heating. Now let's one last check. Let's do one more thing on the heater itself. I want to do it while we have the board out so you can see it a little bit better. And that is, we're going to check between these 2 tabs right here. And those are the 2 electrodes. This particular one is a 5.5 kW heater, so it should check about 10.5 k ohms. So if you just put it in the ohms setting, ohms, it should say about 10.5. Don't worry about the K. It's actually showing open. No, it's not. There we go. Get a good connection. So it's just a connection issue. I'm not getting a real good connection. But you see on heaters, there it is, 10.7. So the thing about heater elements is this: there's no degrees of good. It either is open or closed. So if you get a measurement like this right here, if it was a 4 kW, it would measure higher. It would measure about 13.5, 14, somewhere in that neighborhood, 14.5. As long as it measures, it's good. It's just that simple. So you see where the blowout was on the back of the pack right there. So we're going to fix it. Stay tuned. All right, so I have got it jumped out. And what I did was actually added a jumper to every circuit. So over here, this is the black leg coming in, and you see it goes and it spreads wide right here. And there's 2 tabs here on this side of the fuse, and then there's 2 tabs on that side of the fuse. We don't want the fuse to be handling the power of the heater, so I put it on this side. So that jumps to the top, to the first part. It jumps to basically there. And you see how the relays are. It jumps from there to there. Those 2 are tied together, and then from there to there. And you can see that that's discolored and this is discolored, and this is messed up too bad to repair. You see, it's just no good. So I replaced from there to there, and then I did a jumper from there to here. So we're going to put it back in, and I'll show you that it will, in fact, now heat. Stay tuned. So when you first fire a tub up that's got a Balboa system in it, the newer M7 system, it'll go into prime mode. And the purpose of that is so you can hit the pump, make sure that it is, in fact, moving water, which in this case, this one is. Once all that's done, to get it out of prime mode quickly, just hit the temp up or the temp down button, and it'll go ahead and start doing its stuff to go through and calibrate, and then the light will come on. In about a minute and a half, that red light right there or yellow light will come on, and it'll do about an 8-second test fire of the heater to calibrate the sensors. Then it'll calibrate for a minute, minute and a half, 2 minutes, then it'll come back on steady. So I'm not going to bore you with all that, but that's getting ready to happen. And then we'll have heat. Stay tuned. Shortly, you will see about an 8-second test fire. And what it does is fires the element and you've got a sensor here and a sensor here. This is M7, and it shows the element a 3-degree temperature. What it's looking for is a 3-degree temperature raise between the two sensors. If it has that, it knows there's water in the tub and it's okay to recalibrate and heat, or finish the calibration and heat. And the other thing it's doing is determining the movement of the water. In this case, the water's moving this way. So that would become sensor A, this will become sensor B. Normally this is A, that's B. There's your test fire. So you see that it is in fact heating, like I said it would. Now it's going to calibrate, and then it'll come on and heat steady. So that board is repaired by doing jumpers. I wasn't able to fix the solder joint because it's too messed up. So I jumped from this area right here, which is on this side of the fuse. I'm not going through the fuse. So that's the black leg running through, and it runs through the whole system. There you go. And then that jumper there to the bottom, it's hard to see, I know, because it's dark in here. That jumper's right there. So just make sure when you're doing this that you don't jumper the relays closed. You should be able to watch your meter and see the heater come on and go off and do all of its normal stuff. So now it's in calibration mode. Once it comes out of this, you'll hear everything go off but jet 1, pump 1, and you'll hear the heater come back on. You'll hear it click, and you'll see current draw right there. It's cold outside, and the water's cold, so it's in an ice situation right now. I'm gonna power down, power back up, and show you it. There she is. So the heater works now, and this jumper, the one that I added from here to the top, was not necessary because there wasn't an issue, but it takes the pressure off the board, off the printed circuit. So from here to there, from there to there, from there to here, and it bypasses all of the printed circuit on the board and just makes it a little more beefy. I don't know why they don't do that from the factory, but they don't. And I'm talking about Balboa, the manufacturer of the board. So there you go, friends. That's how you repair that particular setup. And this one is a VS 520, but that will work on the 510, a 501, a 500, a 300. It may not have this jumper here, but the rest of them are usually on those boards. I tightened up and got her fixed up. You do the same. So friends, this is a spa guy, and I don't know much, but I do know hot tubs. This was a simple fix, was not that big a deal, and I bet a lot of you bought boards when you could have fixed it just like that. So if you've replaced your board and you still have the old one, you flip it over, you see that cold solder joint, I bet you can fix it just like I just fixed this one. You can have two boards, a backup board for your other board. Thank y'all so much for watching. Don't forget to go down in the description area and click on the link to go to my website, Hot Tub Parts of America. That's the whole point of any of these videos. I give you instruction of how to save money on something like this, and you buy your parts from me, your filters, your chemicals, covers. We manufacture covers, all those things. Anything that you need, we'll try to help you. Unfortunately, on a lot of tubs, we're getting to a point where a lot of things are obsolete now. They're not making some jets that they've made forever. They're not making topsides. They're not making all kinds of stuff, but I can help you with solutions. We have a service where you fill out some information and I do my best to answer. Now just understand there's a lot of you and there's one of me, and I'm generally the one that answers most of those questions, so it sometimes takes time. It's not going to be overnight or in one day a lot of times, because it takes me time to get to them and answer them all, especially if you send me a hard question. I try to give you a solution for it. Thank y'all so much for watching. I am the Spa Guy. And don't forget to go to hottubpartsofamerica.com. Tighten up and go there now.